common reason to use the Trader Workstation API is to place orders to an interactive broker account from a third party or custom software. This might be part of an automated strategy or caused by manual user action in the API client's graphical user interface. In this lesson, we will discuss the place order function in the API eClient class, describe how it is used for order placement, as well as describing those functions which are used to monitor order status and execution information. For reference, there is a section of the API reference guide which documents these functions in detail and has many examples of defining different types of orders and contracts. Essentially, any order type which can be placed from TWS can also be placed from the API. This includes advanced order types such as IB algos, bracket orders, and conditional orders. Most, but not all, order attributes can also be used with the TWS API. In general, order attributes must be set from the API by defining different fields within the API order class when an order is sent. However, there are also some attributes which will be read from the presets in the session of TWS or IB Gateway to which the API client is connected. Interactive Brokers offers over 60 types of orders and attributes and provides access to more than 100 exchanges worldwide. This leads to an immense possible range of combinations of order types, instruments, and exchanges. The best tool to use to check if a particular combination of order type, instrument, and attribute is valid is TWS itself. Before creating a particular complex order from the API, it is always recommended to first check if the same order can be created in a TWS order ticket. If the combination is invalid, generally this will be indicated by TWS because either the order type will be grayed out or not displayed for that particular combination. For a simple demonstration of invoking the place order function and receiving the associated callbacks for monitoring orders, we will show how to place an order in a paper account for the US NASDAQ Apple stock using a simple program. Before placing any API order to a live account, it is always recommended to first place the order in the paper account to verify that it's being placed as intended. Paper accounts are offered to all Interactive Brokers accounts holders, and demo accounts can be accessed even before a live account is opened. Okay. Next, we will look at the sample code itself. Here I have the PyCharm editor open. I've opened the TWS API installation folder, which is on the C drive, and then just open that up to the testbed folder where the samples are. This is the source folder called Python client, and I had to mark this directory as source in order to include it in the Python path. That can be done just by right-clicking on it and moving down to mark directory as source. Then after doing that, you'll find the program.py sample program, which can be run directly. And here, as an additional demonstration, I've also created just a very simple script called place order, which demonstrates how to place an Apple order through the API. The parts of the sample program will look very familiar if you viewed the previous lessons, which demonstrated the rec contract details, rec market data, and rec historical data functions. In this program, we again create a test app class, which derives from both eClient and eWrapper. But here, instead of overriding the functions as we did previously, we'll override functions related in eWrapper placing and monitoring orders, namely next filed order ID, order status, open order, and exec details. The callback next filed ID, you'll see at the top here, is used to receive the next filed order ID, which could be used by that API client at that particular moment to place a new order. Order IDs larger than this value would also be accepted. The next filed ID callback is invoked in response to the API client, either calling the function recIDs in the eClient class, or additionally, is also automatically invoked after the initial connection is completed. Here we will demonstrate how it's best to wait for the next filed order ID callback after the initial connection before invoking any additional functions and sending messages to TWS, which in this case will be place order. After connection, the sample program here will enter a run loop. The run loop will then start processing messages in the queue and calling the associated functions in the wrapper. When it finds the next filed order ID, which is called after that initial connection, we will first store the next filed order ID into a global variable as it could be used later in case additional orders are sent. And we also call the start function, which actually invokes the beginning of the program to define the contract object, the order object, and invoke place order. So to uniquely identify an Apple stock, we'll do it in a way very similar to the previous lessons. We'll define it using the symbol, security type, exchange, and primary exchange. Since Apple's listed on NASDAQ, that will be our primary exchange field. Then we'll also define exchange as smart, because this will be a smart routed order. Smart refers to IB's proprietary smart routing algorithm, which looks at all available exchanges on which a particular instrument trades. For the order object, we've decided to place a limit order. So in addition to the fields which are almost always defined, or the total quantity, which is the total size of the order, the action, which could be buy or sell, and the order type, which would be LMT for a limit order, we also need to define a limit price. It's important to keep in mind that when defining order prices for stocks, that there's a minimum increment which can be used. For Apple stock, for instance, this is 1 cent, so orders can't have prices specified with more than 2 decimal places. There is more information about finding the minimum increment for different instruments in the API reference guide online. Now that we have the order ID, the contract object, and the order object, we can invoke placed order. After TWS will receive a bound order, it will begin sending back messages to the callback functions order status, open order, and exact details to indicate an order status as well as any changes in order status which occur. For instance, in this case, we would expect to see for an Apple limit order placed during market orders that there would be an order status callback of submitted, an open order callback with the order details, and then eventually possibly an exact details callback if the order executes. Here, all we've done with those callbacks is to override them with a simple print function to print all the returned information to the console. In a production application, that information would be stored differently, or it would trigger conditional logic to perform other actions. So after every submission of an order, as soon as the order is valid, usually you would see an order status callback, which could be either pre-submitted or submitted or filled. Sometimes there will be duplicates which might need to be filtered out by the API client. If the order executes, there will always be an exact details for every partial fill. So if there is more than one fill for a particular order, you would see multiple callbacks, exact details. That callback would have information such as the order ID, which would be different than the API order ID. This is an order ID which is unique in the account and generated by TWS. You would see the number of shares which have executed. You would also see a last liquidity flag, which would tell us if this particular execution either added or removed liquidity from the market. Okay? So in this example, after that's done, we have also set just a very simple timer here, which just waits 3 seconds and then calls the stop function here. And that does nothing but stop the run loop and call disconnect. So we have a clean disconnect at the end of the program. Okay? So I already have TWS running and listening in a paper account on socket port 7497 with the API enabled. Okay, so I can go ahead and run the script, and that should immediately place the order for Apple stock, a buy order for 10 shares at a limit price of $2.10. The time enforced by default is day, so this would just be a simple day order. Okay, and then if we scroll down to the bottom, we can see we got an immediate execution. That's because the current price of Apple is at $196, and this is during market hours, so the order immediately became active. Before that occurred, the callback we first got was open order. We got an open order callback to let us know the details of the order. So we have its order ID in the callback, the security ticker symbol, the security type, the exchange, and the other order details such as the action and the type of order. We then received an order status callback, which indicated that the order was in the pre-submit state, which just means that it had been received by TWS, but had not been submitted to the exchange. Okay? The next order status we received would be a filled status, because the order filled pretty much immediately, at least in the paper trading simulation engine. And that tells us how many shares filled, how many remaining, and also the fill price. Okay? And we also received an execution details, more or less simultaneously with that order status, to let us know information like the execution details ID, as well as the same information about the number of shares which filled and the filled price. So you can see there are different order status combinations which can be received for an order. Sometimes you might receive a pre-submitted, then immediately a filled, or you might see a pre-submitted, then a submitted, then a filled. So these can occur depending on market conditions and different orders. So that's our example of placing an Apple stock order. Now we'll discuss briefly some other information about placing orders and modifying orders, which is important. The API client can also be designed to receive information about orders placed by other means, such as orders placed in TWS manually or by other connected API clients. This can be done in several ways. At first, an API client can invoke the function rec all open orders to receive a snapshot of all order status updates, all order statuses information for all orders in the account at that moment. Second, the API client can bind orders which don't yet have an API order ID using the function rec open orders or rec auto open orders. So orders which are placed in TWS manually will have an API order ID of 0 since they weren't created from the API. The function rec open orders can be used to bind orders which have already been placed in TWS manually, whereas the function rec auto open orders can be used to bind orders which will be placed in the future. The process of binding an order will assign it an API order ID, and that API order ID in a bound order can then be used to cancel or modify the order. Third, an API client can use the master client ID setting in TWS or IB Gateway. This is a setting in the configuration menu in TWS or IB Gateway, which will define the particular API client as the master client. The designated master client will then automatically receive order status updates for all open orders. Orders can also be modified from the API client. To modify an open order, an API client would invoke the same placed order function with the same order ID of the open order, and also use the same contract object that's already in the open order and the order object, but only slightly modified to have the field change which is to be modified. Generally, this could only be the order price or the order size. API clients can only modify their own orders, with the exception that an API client connecting with order ID with API client ID 0 can also modify orders placed manually in TWS. But API clients would not be able to modify orders placed by other API clients. There are some important limitations on API order placement to keep in mind. First off, there's a rate limit of only 50 messages per second in general, which can be sent from an API client to TWS. This limit applies only to outgoing messages and not to incoming messages sent from TWS to the API client in the opposite direction. Functions in the client, such as place order, are associated with a single outgoing message, so an API client can send at most 50 orders per second if it's sending no other messages. Additionally, it is important to bear in mind the order efficiency ratio, which tracks the ratio of messages sent, or submissions, modifications, and cancellations, to the number of orders which actually execute. In general, this ratio is expected to be around 20 or less and is automatically tracked by the interactive broker servers. The commissions for API orders would actually in general be exactly the same as an order placed by any other means. There are a couple exceptions, one of which is for direct, as opposed to smart route US stock orders. Executions which result from direct route stock orders have a commission of 3/4 of a penny per share, whereas executions from smart route stock orders would have a commission of 1/2 penny per share under the fixed commission structure. Additionally, there is also a fee for canceling European futures orders in some cases from the API. More details are available on that from the website. In terms of executions, an API client will automatically receive information about executions in real time about orders that it has placed, but it can also use the function rec executions from the API to query executions in the account which have occurred during the current day. Generally, only execution information for executions which have occurred since midnight would be expected if connected to IB Gateway or TWS. For much older execution data, it is possible to gain programmatic access using the Flex web service or by looking into statements and account management. That concludes our lesson for today on placing orders. Please join us for our next lesson, which is about receiving option chains, portfolio data, and also account information.